Hey, what's up, guys? Sorry I'm not in today, but I did want to go through the homework, or not the homework, the review sheet answers with you guys. So that's what we're going to do today. So starting off with the first page, number 1, in the diagram below of line ABCD. So this line right here, let's get this to lock in. Okay, we know that AC, which is this entire line right here, okay, is equal to BD, which is that whole line right there. We want to know is what using this information, what can be proven? So can we show that this line BC is the same as AB? And that would not going to really work, but really what you want to notice is that when these lines here cross, right? Essentially this line has these points BC on it. So if I could, right, subtract away this BC from both, what I'm really going to get left with is the part outside here and here that's going to be the same, if you guys see that. So if we take away the middle part, okay, we're going to get left with AB equaling CD, which is really what we want. So remember our proof, we were doing a proof, right? We have AC is congruent to BD, and then we pull these apart and do AB plus BC is congruent to BC plus CD. And then we're just able to subtract, right, the BCs from both sides. And that's where the AB congruent to CD is coming from. Okay? Same thing with angles. You can do that too with angles. So if I have, for instance, these 4 angles coming off here, or even just 3, 1, 2, 3 angles, right? I can even say, what if I know that 1 and 3 are the same, right? What can I show? What I can do is combine 1 and 2 to make this big angle, and I can combine 2 and 3 to get that big angle, right? And I can show that those two are equal too. So that's a couple other options you have here. All right. Number 2, in the diagram below, lines L, M, N, and P intersect at line R. Which statement is true? So let's just start with these 2 lines right here, right? If they were equal, okay, what angle, let's say, would this 112 degree angle be equal to over here? We would say, well, it'd have to be this guy right here. So if these were equal, right, that means this should also be 112. So let's check it, because we know this is 78. So if we take 180 and we subtract 78, we're going to get 102. So that's obviously not the same as that. So these lines are not parallel, right? L is not parallel to M. Okay? Now we're going to keep doing that. So let's just go actually check the lines here. So number 1 is L parallel to M. Well, this line and this line should have these 2 angles on the outside here should be equal, right? And they're not. These are alternate exterior. They're not equal. They can't be parallel. Okay? So one's out. What about L and P? So if this line here were parallel to this line here, right? This angle and this angle right here would be corresponding. Or even this one and the one down here would be alternate exterior. So it's up to you. The question is this 112? If it is, then the lines are parallel. So we already know that this is 68. So if we take 68 away from 180, we do get 112. So since these are 112 and they're equal to 112 that's there, that means that these are parallel. But let's keep going. Let's take a look at M and P, right? This is 78, this is 122. So the question is, right, are these guys equal? And if we take 180 and subtract away 122, we actually get 58 here, so they're not the same, and that's why those are not parallel. And then M and N, it's kind of the same thing, right? If this is 78, what do we just do? M and P. Well, this should be M and N, so that would be why that's not the same. But let's look at M and P now. So same concept. If this is 78, right, then this should be 78 because they're alternate exterior. It's not, so this is why there's not parallel either. So if we're showing the justification to justify, just this work we did right here would be enough to show that it's the same. So showing that this is 102, or showing that this is supposed to be 58, or that this is supposed to be 112, and it is good enough. Okay? It says explain. Then you're just going to want to explain, for instance, in words, like the 112 and the 60-degree angle are supposed to be supplementary, and they are, therefore the lines are parallel because they're same side exterior. Would be fine. Okay, number 3, in the diagram below, transversal TU intersects PQ and RS at V and W respectively. TVQ is 5x minus 22. One thing I recommend is then labeling that on your diagram so that you know exactly where it is and you can reference it when looking at the other angles. VWS here is 3x plus 10. For which value of x makes the lines parallel? So if which of these x values is going to make these parallel? If these are parallel, these two angles are in the same position, they're corresponding, right? Which means that they are congruent. So I come over here, set up my equation, 5x minus 22 should be equal to 3x plus 10, and then I can solve. So take 3x away from both sides, leave the x positive, add the 22 to get 32, and then divide out by 2, and x should equal 16. Now go back and read the question. It says find the value of x. Sometimes it will specifically say, like, what's the measure of TVQ or VWS? So make sure you just double check. Does it want you to plug in, or can you just use this answer? And here we can use the answer. Okay. Number 4, based on the construction at right, which statement must be true? So this is an angle bisector, right? So what do we know? We know that this angle here is the same as the one down there. So we know that angle ABD is equal to angle CBD. And we also know that if I double this small angle, I get the really big angle back. So 2 times ABD, right, is equal to ABC. All right? And then we can flip it. I can say that one of these ABDs is equal to half of angle ABC. So if I take half of the really big angle, I should get that one back. And you can switch ABD right with CBD. So it's the same concept. 2 times angle CBD is equal to angle ABC. And then half of angle ABC is equal to angle CBD. Let's go through and check. Is ABD, right, this small angle, equal to half of this other small angle? And that would be no, right? They're supposed to be equal, not half. Is ABD, this angle right there, equal to CBD? Yes, that's true. Is ABD equal to ABC? No, because this is the biggest. And this half of ABD, which would be no, equal to CBD. So it's choice 2, because that's the angle bisector construction. But this is the one you're going to want to pay attention to, these guys. So really focusing on the doubling the small angle is equal to the big angle, and half the big angle is the small angle. That's usually what comes up there. So just be careful. Okay? Diagram below shows the perpendicular bisector, which is not true. So focus in on the not true. Okay? Because 3 of them are going to be true. So perpendicular bisector, right? Bisector is the key word here. That means that AC, right, is going to equal CB. And that's choice 1. So that is true. We want to get rid of it. Okay? It also means that if I double either of the small halves, I get the really big half. So 2 times AC and 2 times CB is going to equal to AB. Okay? And here's AC equals 2AB, right? Oh, well, we'll come back to that one. Okay? The other thing we know is if we add together AC and CB, we're going to get AB. So this is also true. We don't want it. And then we know that if I take half of the really big segment, I'm going to get one of the small segments. Okay? Which is what this says. So we want choice 3, which is false, because if I take 2 times the big side, that is not equal to the small side. That's the one that's false. So just make sure you pay attention to like where the 2 and the half are, stuff like that here.